Anytime you are troubleshooting a product, always eliminate all other primary components as a possible source of the problem before cutting into the sealed system. Some things to look at would be power. Make sure you've got 110 volts reaching the system. Check the gaskets for leaks or imperfections. Are the interior lights staying on, causing excessive heat? Check all the fans. Also make sure interior vents aren't blocked and that the condenser isn't excessively dirty. Finally, is the defrost system functioning properly? If all of these systems are functional, do one more thing before cutting into the system. Check its electrical draw. If it's pulling normal amps, then the problem is not in the sealed system. But if your reading is high or low, get out your process tools. There are two common problems that can arise in a sealed system: leaks and restrictions. Beyond that, there are a few less common problems. Each problem can be identified by comparing and contrasting the readings on your gauges and your meter with the status of the evaporator and condenser. These readings will be abnormal in various ways based upon the problem at hand. It's important to understand that the readings we show in this program are based on a normal reading that would be found in 70-degree Fahrenheit ambient temperature. We cannot tell you what normal is on your service call because normal fluctuates with ambient temperature. Low side leaks are characterized by low pressure readings on the low side and high readings on the high side. The system will pull more amps than normal. The evaporator may be only partially frosted, and you'll hear some hissing and gurgling coming from it. The condenser will feel slightly cooler to the touch than normal. To locate a low side leak, look for bad joints, joints with cracks, signs of oil residue around them. High side leaks will feature low readings on both the low side and high side, with a low electrical reading. The evaporator may be only partially frosted or not frosted at all. You should hear some hissing and gurgling at the inlet. And you should find the condenser slightly cooler than normal from lack of pressure. Also, the compressor will run very cool and quiet. But wait, if these conditions make this look like a high-side leak, check the service history on this product. If it was recently serviced, it may have been short-charged, and short charges give gauge readings nearly identical to high-side leaks. Go ahead and look for a leak, but don't be surprised if you can't find one. You'll know for sure when you pump down the system if it can hold a vacuum. Look for high-side leaks the same way as the low-side leak, looking at the joints, but because of the higher pressure, you can more easily find these leaks with bubbles or with using a leak detector. Partial restrictions will feature low readings on your low-side gauge. It may eventually pull into a complete vacuum. The high-side gauge will read a little higher than normal, and the system will pull lower amps or watts than normal. The evaporator may only be partially frosted and may have a ball of frost at the inlet, and you'll hear some hissing and gurgling coming from it. A total restriction from moisture or debris caught in the cap tube is a little easier to identify. You'll find the low side in a complete vacuum, with the high side only a little above normal pressure. The electrical draw will be low, with all of the refrigerant pumped out of the evaporator, and you'll find no frost on the evaporator. These less common problems should not be overlooked, especially if the system has been serviced recently. A worn or damaged compressor could be the result of heavy contamination from a low-side leak. Has the system been serviced? One symptom that should stick out with a bad compressor is the low-side pressure reading. It will always be high due to the compressor's inability to draw down that side of the system. For the same reason, the high side will also read low, and because the compressor lacks compression, the amps or watts will read low too. Another symptom that helps diagnose this problem is the lack of frost and the lack of hissing or gurgling at the evaporator. You will also find the condenser much cooler than normal. Over or undercharging a system occurs when servicers fail to follow Electrolux's evacuation and charging procedures. They must be followed precisely to assure proper charging. Overcharging from a previous service call would show up as a high-pressure reading on both sides of the system. How high depends upon how much additional refrigerant is in the system. And because the higher pressure makes the compressor work much harder, the electrical readings will be high. This system has more refrigerant than it needs, so you'll find a heavily frosted evaporator. The most unusual visual clue that you'll see is that frost has even developed on the suction line. Charging a sealed system correctly, without leaving any refrigerant in the hoses or manifold, requires following a specific procedure. Varying from that specific procedure even slightly can result in short charging a system. As mentioned before, short charging diagnoses almost identically as a high-side leak. The only way to confirm it is to see if the system can hold a vacuum. A system with air in it is uncommon, but could result from a poorly executed charge. The low side will be near normal, with pressure on the high side higher than normal. Electrical readings will be low. The evaporator may only be partially frosted, and you may hear some hissing and gurgling coming from it. But the condenser will show a small temperature differential between the inlet and outlet.